Hello students, in this video we are going to discuss about the redox reaction in terms of oxidation number. In the previous video we have already discussed some of the definitions for oxidation and reduction, that is the reaction in which both oxidation and reduction is taking place simultaneously. That reaction is called as redox reaction. So some of the definitions we have already discussed for the oxidation and reduction. These are: the addition of oxygen is called as oxidation, but the removal of oxygen is called as reduction. In terms of hydrogen, we can say that the removal of hydrogen is called as oxidation, but the addition of hydrogen is called as reduction. In terms of electronegative element, we can define oxidation as addition of electronegative element is called as oxidation, but the removal of electronegative element is called as reduction. In the same way, in terms of electropositive element, we can define oxidation as the removal of electropositive element is oxidation, but the addition of electropositive element is reduction. From this, the most important definition for the oxidation and reduction, as I told you, this definition, that is loss of electron is oxidation, gain of electron is called as reduction. Now in this video, we need to discuss the oxidation and reduction on the basis of oxidation number. We have already defined oxidation number and the method to find out the oxidation number in the previous video. So in terms of oxidation number, we can define oxidation as increase in the oxidation number is called as oxidation, and if there is decrease in the oxidation number, that is called as reduction. Look at here there is increase and in the reduction there is decrease. So from these definitions for the oxidation and reduction, from this definition, that is increase in the oxidation number is oxidation and decrease in the oxidation number is reduction. That is the most important definition, because when you use this definition, it is easier to identify the oxidation and reduction. So let us discuss some of the examples. These are the redox reactions in which we need to find it out which one is oxidation and which one is reduction on the basis of oxidation number. So we are taking this example. This is a redox reaction. Now how you identify this as a redox reaction? Let us discuss this one. In this reaction, that is copper ion plus magnesium is giving rise to copper plus magnesium ion. It's a displacement reaction. Now in this, find it out the magnesium, its oxidation number on the both reactant side and on the product side. Mg, that is in the free state, the oxidation number for Mg is 0. So what about the case of Mg2 plus? For the Mg2 plus, the oxidation state, because it is an ion, so whatever the charge it have, that is the oxidation number. So for Mg, the oxidation number is +2. So when you look at from reactant to product side, that is from reactant to the product side for Mg, we can see that there is increase in the oxidation number. That is from 0 to +2. Here the oxidation number is 0 and here the oxidation number is +2. That means 0 to +2. 0 to +2. That means we can say that there is increase in the oxidation number because 0 is changed into +2. That means the oxidation number is increased. So according to the definition, the reaction in which the oxidation number increases, that reaction is called as oxidation. Therefore this reaction is oxidation. Now look at the other one, that is a copper here. Copper in this, on the reactant side, it is in the ion form. Therefore its charge, that is +2, is the oxidation state. So we are writing its oxidation state here +2. But on the product side, copper, it having the zero oxidation state because the copper here is in the free state. That means the oxidation number is 0. From reactant to the product side, we can say that there is a decrease in the oxidation number. Decrease in the oxidation number because we can see that the value is changes from +2 is changed into 0. That means the value is get decreased. The oxidation number is get decreased. And according to the definition which we have learnt already, there is a, if a decrease in the oxidation number, then that is called as reduction. So here in this reaction, both oxidation and the reduction is taking place simultaneously. Therefore, this reaction is called as redox reaction. That means here the oxidation is taking place, this is the reduction and this is the oxidation is taking place, and both is taking place simultaneously. So here in terms of electron transfer, we have already defined oxidation and reduction. That means one is losing the electron, the other one is gaining the electron. Here Mg loses the electron and that is gaining by the copper ion. So oxidation and reduction both is taking place. So the better way is to identify oxidation and reduction. That is the method. Find out its oxidation number and check where there is increase and where there is decrease. There you can easily find out the oxidation and reduction. And here the Cu2 plus is undergoing reduction. Therefore, this is called as a oxidizing agent because it undergoes reduction but it helps in the oxidation. Therefore, it is called as oxidizing agent. What about Mg? In Mg, here it is undergoing oxidation. Therefore, it is a reducing agent. So, as I told you, the substance which is undergoing reduction, that will act as a oxidizing agent, and the substance which is undergoing oxidation, that will act as a reducing agent. So once you have identified the oxidation and reduction reaction, you can easily identify which one is an oxidizing agent and which one is a reducing agent. Just reverse, because which is undergoing oxidation, that is a reducing agent. Which one is going reduction, that is a oxidizing agent. Let us take the other example. In this reaction, when we write out the oxidation state for chlorine, that is in the molecular state it is 0, but here the compound, that is potassium chloride, in which the oxidation state of chlorine is -1, and here the oxidation state for chlorine, that is in the potassium chlorate, it is +5. That means the chlorine is the changes into chloride and well as it changes into chlorate. So here the oxidation state, when you check from here to here, that is 0 to -1. The value is changing from 0 to -1. That means there is a decrease in the oxidation number, therefore it is reduction. But simultaneously here the oxidation state of chlorine, from here to here there is increase in the oxidation number, that is from 0 to +5. Therefore this is called as a oxidation. So here the potassium is not undergoing any changes in the oxidation number, because here also the oxidation state for K is +1, here also +1, here also +1. That means the oxidation state of K is not changing. Oxidation state of O is not changing because it is -2 here, here also -2, here also -2. That means there is no change. Similarly for H also the oxidation state is not changing. This is +1 here, here also +1. So where there is a change, there is only change in the oxidation state of chlorine from the reactant to the product side. So only take that case where there is a change in the oxidation number. So here the chlorine is undergoing here both oxidation and reduction, that is from chlorine to potassium chloride, that is the reduction, but chlorine to potassium chlorate, that is oxidation. Similarly, one more example we have here, that is H2O2, hydrogen peroxide into H2O plus O2. Here the oxidation state of H is not changing, but the oxidation state of O is changing, that is -1 here. Why the oxidation state here it is -1? Because it is a hydrogen peroxide. As we have already learned in the rules, that is oxygen usually having -2 oxidation state, but in the peroxides they have -1 oxidation state. So here the oxidation state of O in the peroxide is -1, but in the water the oxidation state of O is -2, and the oxidation state of oxygen in the molecular form, that is in the homonuclear molecule, it is 0. So here there is change in the oxidation state of oxygen O, that is from here to here the oxidation number that is changing from -1 to, that is -1 to -2. It is changing from -1 to -2. That means the value is decreased. -1 to -2, that is the oxidation number is decreased, therefore it is called as a reduction. But here -1 to 0, that is an increase in the oxidation number. -1 is the lower value and 0 is the higher value. So -2 to 0, there is increase in the oxidation number. That means this is from here to here, we can say that it is a oxidation. So whenever any equation is given to you, better to write down the oxidation state of each terms. That is better to write with any other color instead of better use the pencil and write it out on its in this way on top of it, and then you can find it out where there is a change. That change you can identify that it is a increase in the oxidation number, then that is called as oxidation, and if there is a decrease in the oxidation number, then it is reduction. It is the most important definition for the oxidation and reduction. On the basis of this only, we need to balance the redox reaction. So this is all about this video. Have a nice day.